Today we're beginning our unit on solving linear systems. We're going to first look at how to solve a system graphically, but before we do that we better define what a linear system even is. And we looked very briefly at linear systems in grade 9 math, and we did it through graphing, so this really should be review, but it's really the basis of our next unit. So first of all, what is a linear system? A linear system is two or more lines studied together. Now in grade 10 we only look at potentially two. We don't really get into bigger systems where we have more than two lines, so our focus will just be on studying two lines at a time here. To find the solution of a linear system, what we're doing is looking for the point at which those two lines intersect one another when they're graphed. Algebraically we can find it, which will be new this year. We did look at doing them graphically in grade 9, but we can check to see if we have a solution by seeing if the ordered pair actually works for the x and the y in both equations, and we're going to do that in question 1 below. A couple other things I wanted to outline for you is, or review with you, is discrete data. Those are data values that will be exact values and you're leaving some values out. For example, if you're counting how many people attend a movie, you could have 0 people, you could have 1 person, 2 people, 3, 4, 5, 6, but it doesn't make sense to say you've got 1.5 people or 1 3/4 people. You won't have part values. We're leaving some values out. Shoe sizes would be discrete. You could have a size 7, you can have 7.5, you could have an 8, an 8.5, or an 11, an 11.5, but we don't talk about a shoe size of 11.2 or 11 3/4. It only goes 11, 11.5, 12. So hopefully that makes sense in terms of discrete. When you graph those ones, in theory, they should be graphed as either individual points, depending on the scale, or if it's a big range of values, if you're going from 0 people attending the movie up to 200 people, and on your graph you're going up by like 20s on your x-axis, you can't possibly put in like 20 little dots in one teeny little square. So what we do is create a dashed line for that example. Continuous data is data that can have any value within a range of values. So for example, if we're tracking how long it takes people to finish a 12-minute mile, how long it takes for them to run a mile, you would be tracking people, and the person recording at the finish line could potentially go to like the nearest second or the nearest 10th of a second or the nearest 100th of a second and so on. You could actually go into like lots of infinite number of values. So those are continuous values, and that is graphed as a solid line. If we're not sure, we assume it is continuous. Okay, so for question number 1, verify that this point 1, 2 is the solution to the system. So what we do from there, I'm going to label this equation number 1 by putting a 1 and a circle around it. So I make it a label. I don't want to just put like 1 and then a 2 without a circle, because often this then would become the number 122, and I don't want that to happen. I want it to just be a label. So I'm going to put a circle around that too, so we know that that's a label for it. So we're checking equation 1, which is the 4x plus 2y. So on the left side of the equal sign we have 4x plus 2y, and on the right side of the equal sign we have the 8. Alright, so we start with that. The next thing we want to do is sub in our values for the x and the y. The x is 1, the y is 2. We're going to put 4 times 1 plus 2 times 2, and then we evaluate that. That's going to be 4 plus 4, which is 8. So because the left side was equal to the right side, we know that the point 1, 2 does lie on that very first line. So it is a point on that line. We're going to do the same thing with the other equation and see if that 1, 2 is also a point on the second line. So we have 2x plus 5y, and on the right side we have the 12. Sub in our values. We've got 2 times 1 plus 5 times 2, and then we get 2 plus 10, which is 12. So the left side again equals the right side. Left side equals right side. Left side equals right side. So therefore we know that 1, 2, will be the point of intersection. It's where these two lines are actually going to cross each other, because when you graph them, they both will cross through that single point, wherever it happens to be. You could pull out your Desmos and double check that. So is the solution to the system. Okay, next slide here. So I need to resize. Put that there. Okay, and we are going to, hopefully that's going to work here. We are going to graph each line. In this case, make sure your sketches are accurate. We've got to really work on our accuracy, and then we want to determine the point of intersection by looking at the graph. So we're just going to review how to graph these and how to solve them graphically. This first equation, equation number 1, get my pen back up here. Equation number 1, it has a slope of 2 and a y-intercept of -8. So to graph that, I want to plot a point at -8, and this would be easier on a piece of paper, but I'll do my best here. My slope is 2, which is 2 over 1. I'm going to rise 2 and run 1. I'm going to rise 2, run 1, rise 2, run 1, and so on. I could keep going with that. If I have a ruler, I would just take my ruler then and join them together as accurately as possible and label my equation with y equals 2x minus 8. So part of my communication, this is the x-axis, this is the y-axis. My other equation has a slope of -1 and a y-intercept of 7. So I start up here at 7, and -1 means I'm going to fall 1 and run 1 right, fall 1, 1 right, fall 1, 1 right, fall 1. And what I'm doing is finding that point of intersection. So here's the point right here. That is on both of those lines. Okay, do my best to line those up. Ruler is always ideal. That's +7. So my intersection point, the point where these two lines cross, would be at the coordinate of 5. X comes before y, 5 comma, and the y is a 2. 5 comma 2. So therefore, the solution of this linear system is 5 comma 2. All right, next example here, we're going to graph our lines. Gotta lock this in here. Don't know if that worked. Okay, let's assume it did. We have to rearrange our equations in y equals mx plus b form, perhaps, to help us graph this. I'm going to look at this down here because I don't have a lot of room there. I'm going to subtract x from both sides, and I'm going to have y equals the 3, and then I'm subtracting x, so to get the x away from the y. So we get y equals 3 minus x. The slope is -1. It's in front of the x, and the b is 3. So we're going to plot a 3 on the y-axis, and then I'm going to fall 1, run 1, fall 1, run 1, fall 1, run 1, and so on. Line those up with your ruler. Ooh, I did a really poor job of that one. I'll try and do better on the next one. I've got a 2x plus 2y equals 6. If I solve that for the y, I've got 2y equals 6, and I'm subtracting 2x's from both sides. Subtract 2x, subtract 2x. And I have a minus 2x here. And then I would need to divide both sides by 2. And we're going to have y equaling 3 minus x. So I've got a y-intercept of 3, and I've got a slope of -1. Oh, wait a second. That's going to give me the exact same line. So if I actually did a good job on this, my two lines actually end up lying on top of each other. That means every single point on the line is a solution. So in terms of writing that, like, there's an infinite number of points. We can't just write a specific value. We're really going to write our solution to be, therefore the solution is, and it can be any x value. So I'm just going to put x, any x value at all. and then my y is equal to 3 minus x. It was equal to 3 minus x in both cases. So my y is going to be replaced with 3 minus x. So as long as I pick a value of x, I can sub it in here. Let's say x was 1, then my y coordinate would be 3 take away 1, which would be a 2. So that's one of the solutions. And then I could keep going, 0, 3, and I could keep putting numbers in. There's an infinite number. So when I write it with this ordered pair, that's what states that it's an infinite solution, and it's in that format. Okay, try the next one, graph it, find the point of intersection, state your solution, see how you do.